Okay, so if you're absent on a day when we are doing breadboarding, particularly if you're going to be absent for an extended amount of time and you need to make up the material, then the way that you're going to make up breadboarding activities is in Tinkercad. So I have a Tinkercad slide open here, and what I'm going to do is I'm just going to model how you would breadboard steps 3 and step 4 of, oh, see ya. Breadboard, that was Mr. Rollins just left. Then to breadboard steps 3 and step 4. So over on the right hand side, we're going to look for a small breadboard and just click it and drag it over. And then for this activity, we needed a 6-volt power supply. So you can either do like the power supply, scroll over here, and like I'm not seeing like the little power supply thing, but like we were using the 1.5 volt batteries in class. You could try to put like 4 of those in series, or you can do a search for the power supply, and I think it needs to be, there we go, and just drag that over, because we would use a power supply like this in class if we had it. The only reason that we're using batteries is because that's what we have at the time that I'm recording this, which is what, September 9th, 2021. So let's go ahead and hook that up, and we can change the voltage to 6 volts. So in class, you, oh, seriously, it not gonna let me do it. There we go. You would connect your power to your power rail, and then we would change that color to red if at all possible. Like we want to keep those, whoops, that did not work. There we go. And then change my ground to black, and let me just double check and make sure we've got that. Okay, so now we needed some resistors. So we needed to connect a 2.7, 10, 3.3, and 8.2K resistors. So over here, I'll do a search for, seriously, no. To a search for resistors, I don't even know. Okay, resistor. There we go. And we'll bring that over. We need 4 resistors. So first one is 2.7K, and notice that the bands do change when you do that. Let's go place that one for, well, we'll just do this one. The next one is a 10K. Okay, so to place the 2.7K resistor, we need it connected to power. So I'm actually going to plug it straight into the power rail and then just over the little ravine there. And that should work. You can use like a wire to connect it as well. Now I'm going to rotate this by clicking on it, and then I'll come over here and just turn it sideways. I'm in the upper left-hand corner if you can't see. And then dragging that. Now, remember that in a breadboard, all of these in the row are connected together. So I can like connect it, like, well, you don't really want to connect it to the same pin because that's not realistic, but you can connect it the next pin over. But if you wanted more space, you could actually slide it further down. And the cool thing about Tinkercad is if you forget how the different pins are connected, you can hover over them and you see those little green circles. It tells you what's connected to what. So you know that everything in that like column there is connected together, but not to the stuff on the other side of the little ravine here. And then your power rail and your ground rail. All right, now we need a 3.3K resistor, and I'm gonna go ahead and actually turn that maybe diagonally. I don't know how that's gonna work. I have no idea if this is gonna work. And then I want that in, and that actually does not work. So much for that. Let me turn it a little bit. Oh, there we go. All right, and it needs to be connected to the end of this resistor, and you can put like a little bit more space between it if you want. And then the last one was an 8.2K resistor, so 8.2 kilo ohm, and that needs to be connected to ground. And so so there's my series circuit, like so. So we have it connected to power, and then that's connected here, which is connected over here. Hopefully you guys can, I don't know if you can see my mouse or not. And then it's connected here, it goes back to ground, okay? And then you can start your simulation if you wanted to. There's not a whole lot to show. Now, what we did with our DMM, so in class, so I'm gonna come over here and we'll put in multimeter into here, maybe, multimeter, and I'll drag my multimeter over. So now you've had some practice like working with this in real life. We are going to measure voltage first of all, and I'll go ahead and connect my black lead to the negative end, and if you need to you could share a pin there, but negative end, and then the positive lead to the positive. And like so, I'll go ahead and change that to red. And when I start the simulation, that should give me the voltage drop over that first resistor, which is showing to be 669 millivolts, or 0.669 volts, which I think is what a lot of people were getting on the actual meter. Then I can stop the simulation. And what we did in multisim was we actually put like multiple voltmeters on there, which you could do here too, but it would get really cluttery. Is we can just click the wire and drag the wire to the end of the next one, and then start the simulation again. And we're getting a 2.48 voltage drop. And then, whoops, I'm gonna do that. Move it here and here, and then our next one is 818 millivolts, or 0.818 volts, which I think is what a lot of you were getting again. And then the last one, we would connect the black wire to ground and the positive lead over here, and our last one is 2.03 volts. Now, the numbers that you get like from a physical multimeter versus a simulation versus your hand calculation, they should all be pretty close together, but they might not be exactly the same. And that's just because real life stuff is different, like your hands slip, or we know that resistances have tolerances. And so your resistors might be a little bit higher, a little bit lower than like exactly what the nominal value is. If you accidentally like connect one of these up backwards, so you go to measure it and you're just not paying attention, and so you have them crossed, you'll end up with a negative voltage, and that just means that you have like your leads crossed, so it's like a waterfall going uphill or something. All right, so that's how you would do the first one. To do the second one, I'm just going to, well, the second one is all in parallel, so I think we should be able to do this by rotating like the component and then just dragging it. So like they're all going to be just connected together in parallel. We'll just go ahead and connect. Oh, I like to slide this one over. And then we do need to connect them back up to ground. So like these, let me get these guys out of the way. They're just annoying. That worked perfectly. Well, so much for that. So you've got like all of these are connected to power, and then this side over here actually needs to be grounded. So I need to move that out of the way. There we go. So we'll just take a wire, and this side, like they all need to be connected. Yeah, because none of these are connected together. Okay, so I'm gonna do this. I'm gonna run like a little cable here, and we'll make it black, and then one from here to here, and then one from here to here. And what I did there was I just connected all of these resistances together, and then we'll run this one. Now, what you can do, like if I run my wire like this back to ground, like that's fine, but you can see that it's visually like really messy, like the wires going like right over the resistor there. So what you can do, kind of like in multisim where you can like click to kind of give yourself more space, you can actually click anywhere that is not a hole and it'll like anchor the wire there so that you can do something like that. And you can kind of create a bend in the wire so that you're not running your wire right over the resistors. Somebody, like some of the people in my summer class, like were so good about being able to do that. And I stank at it. Like they were really good. They would color code their wires for the different parts of their circuits, and they just were really, really good about it. And like mine looked like what's called like a bird's nest. Like it just, I have issues with that. All right, so for this one, we wanted to, what did we want to do for this? Turn it over. So breadboard the circuit. Step 8 was breadboard it from step 3. Step 9, breadboard it from step 4, and then use the multimeter to measure the overall current. So you actually have to split up your circuit to do this, which is kind of a bummer. And then you have to insert the meter into the circuit. So this beautiful wire that I just put here, I'm going to go ahead and delete it. And I'm going to put the multimeter in its place. So I'm going to have the multimeter actually connect. Okay, we'll turn that red, I guess. So pretty much here's what the current is doing. It's coming out, and then it's going into the rail, and it's dividing between the 4 resistors, and then coming back together again, going through the multimeter, and then into the ground rail. Now, the problem I have with this is that it's still set for voltage, so I'm going to click on it and change it for amperage, so that'll it'll measure the current, and then I'll click start the simulation, and I've got about 5.37 milliamps, which matches about what Multisim gave us, and hopefully is similar to what those of you that did the activity in class were able to get on the multimeter. So anyway, this is what I want you to do if you're not in class on a day when we breadboard, or if we have like a substantial delay in getting our supplies, and then like we kind of have to revert over to the breadboard, like the simulated breadboard to learn the skill. If you need to find like any kind of part, you can do a search for it over here. So you can search for like, you can see over there, LEDs, we have capacitors, different kinds of batteries, different kinds of switches. We have the Arduino, we have motors. And then if you do like a search for, we haven't done like the logic stuff yet, but like you can search for these. We have a Hex Inverter. And so you can do a search for any kind of chip and just like slide it in. And I think I showed some of you in class physically how that works, because I was walking around with some kind of chip today. But that little ravine in your breadboard is to accommodate the chip so that you don't accidentally connect like one pin to another pin. I do think also that there are like bigger breadboards. So we have like a mini breadboard, and we have like a regular size breadboard and stuff. It defaults to a small one, so you can kind of use the breadboard for the size of whatever you're going to do. All right, so this video was just to kind of bring you through that, and to also help you know what to do if you're absent, like how to make up that piece of this course.